Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look again at the use of the resource command to enable file embedding and installation. When doing development, there comes a time when you wish to roll your application or system out to the users. When developing in PowerBasic, most of the time this will involve a single executable file. However, there will be times when you wish to roll out a package, a collection of files, some of which are binaries and some text. Traditionally, this has been done using packaging software, like InstallShield or InnoSetup. These application packages have been around for many years. However, what we're going to look at today is the use of the resource command to embed files within your application, and to bring them out when the application first executes. So let's go and have a look at our code. This is our application. The first resource command we're going to use is to allow us to embed an icon inside the application. This will show when you go into File Manager. This is easily done by using the #resource command followed by the word icon. This instructs PowerBasic that we wish to embed an icon inside the application. The next parameter is the resource identifier. In this case, we're just calling it appIcon. And the final parameter is the path and name of the icon file. So on compilation, PowerBasic will look for this file and embed it into the executable. The next most common use of the resource command is to embed version information. And again, we can do this quite easily by using the resource command. We're specifying the version info and the file version and the product version details. We can of course go further and complete the remaining parts of our version. We can use the string info command to set the language ID and the character set. If we look at the help file which ships with PowerBasic, we can see what the options are. There are many different language IDs and character sets you can use. We can complete this section of the resource command by using version $, allowing us to set things like the company name, the file description, the internal names, and so on. So if we attempt to compile our application now, it compiles cleanly, and if we have a look in the File Manager, there is our executable with its icon already added. If we right-click on the file and look at Properties, and go into the Details tab, we can see all the details of the version information now sitting on our screen. So we have successfully added version information to our application. As you will see in the File Manager, we also have a file called testdata.csv. If we open that up, we can see this is obviously some kind of configuration file. If our application depends on the presence of this file, we need to ship it out with the executable. So today we're going to use the rcdata command in resource to embed this file within our application. And this can be done quite easily by using resource rcdata, followed by an identifier and the path and the name of the file that we wish to embed inside our executable. If we attempt a compile once more, it will compile cleanly, and we will see our executable has now become slightly bigger. So now that we have that file embedded in the executable, how can we get the file out at runtime? So we're now going to go into the pp-main function to test for the presence of that file and to pull it out of our resource and save it to disk. We can do that quite easily by using the inbuilt isFile command. If this returns false, then the file does not exist where we have checked for it. If it returns true, then the file already exists. So if the file does not exist, we'll need to extract that from a resource and save it to disk. So we're going to create a new function to perform the saving of resources. And we'll call that new function saveResource. It will take two parameters: the path and the name of the file we wish to save, and the resource identifier. As we put this into the resource using 4000, we're taking it back out using the same identifier. If this function returns true, then we can see that the resource data CSV file has been saved. If it returns false, we will report that we are unable to save the data CSV file. So let's now go and create this new function. So here is the skeleton of our new function taking its two parameters. So we're going to create two local variables, one to be used as a file handle and one to contain the data that's currently sitting in our resource. And we're going to embed this in a try-catch block to allow us to catch any errors that occur. Our first job is to pull the information out of the resource. And we can do that quite easily using the resource $command. It takes two parameters. Its first, in this case, is RC data, which is where in the resource we're obtaining this information, and the second is the handle to identify the part of the resource that we are interested in. This was our second parameter to this function. This command will deposit into our data variable the contents of this resource. Having obtained that, we can now attempt to open our file to save the information. And we're using the free file command to obtain the next available handle. And we're opening our file name for output and using the handle we have just obtained and printing out with no carriage return at the end our data. If it gets this far, we can return the function true. Should any error occur in here, we're going to return the value false. And our final task in this try-catch block is to close our file down. So if we attempt to compile that, it compiles quite cleanly. So our file should now be embedded in the executable. So how should we test this? Let's create a separate folder for testing. And we will copy our executable into that folder. So in this folder is only the executable. If we double click on it, it runs. It's telling us the resource data CSV has been saved. And if we have a look, we will see that file is now existing within that folder. If we open it up, we will see the original data is now visible. So we have successfully embedded a CSV file inside our executable, tested for its presence when the application runs, and extracted it from the resource should the file not exist. If we run the executable once more, it will not give us a message to say it's saved anything because the file already exists. So you can quite happily take this approach with any number of files within your application. So as well as embedding text files and CSV files into your application, we're now going to try embedding a dynamic link library. So first of all, we'll need one of those. So we're now in PowerBasic for Windows, which will allow us to create a DLL. This is a very simple DLL with only one exported function. And here is that function, called half-a-value. It takes only one parameter, which is passed as a single value. And all the function is going to do is to divide that value by 2 and return the result. So if we compile that, that will give us our DLL. So there is our simple DLL.dll. So we're now going to embed that within our application, just as we did with the CSV file. And we can do that just as we did before, using the resource RC data command, with another unique identifier and the path and the name to the file we wish to embed. So if we compile our application now and have a look at the executable, we will see our resources executable has got even bigger. So we will now use the same approach to extracting that file from the executable. So we will test for the presence of that file using the isFile function, just as we did with the CSV file. If that returns false, we will call our existing saved resource file, saving this resource to this file name. So if we compile that application now and go back into our file manager, we'll copy our resources exe into the other folder, our test area. So in here, we have a CSV file already, but we have no DLL. If we run the executable, it will tell us that the DLL has been saved. And if we look inside the folder, we can see there is our DLL. However, now that we have the DLL out, comes the dilemma of how we reference the DLL inside our application. There are two ways of referencing a DLL: early binding and late binding. If we use early binding, the DLL must exist when your application is executed. If it does not, the application will throw an error and terminate. So as the DLL may not exist in the folder, the application needs to use late binding. So let's add to our code to allow us to test the DLL after it has been extracted. First of all, we're going to create two variables, one for a value and one for the new value after the DLL has run. And there are our two variables. We're setting the value to be 10, and we're printing that initial value out to our log. Now we need to initiate late binding on this DLL. We're going to need two variables. The first is a handle to the function that we're going to call within the DLL, and the second is the name of the function that we are going to call. So first, let's set the name of the function. And here is the name, fun half a value. Now we can set up the late binding. We will first define a variable that's going to be used for the handle of our library, the DLL. Next, we're going to call a Windows API function to load this library into memory. If the value returned by load library is not 0, then our library has been loaded. Next, we're going to call another Windows API call called getProcAddress. This will return the address of the process that we wish to call. It takes two parameters, the first being the handle of the library, which we obtained a moment ago, and the second is the name of the function that we wish to call. And again, if this returns something other than 0, then we have got the address, which will allow us to call the function. If it returns 0, then we did not get the address and cannot find this function in this library. So now that we do have the address to call the function, let's call the function itself. And we can use the call dword function to allow us to call this external function. Taking the handle of the process and using this function name, which we will define in a moment, and it's going to handle one input variable, which is our current value, which, as you will remember, we set as the value 10. And we're getting the output from this function and putting it into this variable, the new value. And we can then print that new value out to our log. Before we leave the pbmain function, it's important to free up the library when we're finished with it. And this could be done quite easily by using another Windows API call called freeLibrary, taking its single parameter, which is the handle of the library we obtained earlier. So now we have to get back to this function, which currently does not exist within our current application. So we define this at the beginning of the application. And here is a declaration for the function we're going to be using. We're referring to it in this application as getValue, taking one input parameter and getting back a single value from that function. And as you will see from the call command, we're using this reference internally, but we're using the process within the DLL. So if we attempt to compile our application now to make sure it compiles cleanly, and we will copy this into our test area. And now we can attempt to run it. And it will take the initial value of 10 and it divides that by 2 in the DLL and returns the value 5. So we have a working DLL which has come from inside your own executable. However, as the DLL is only extracted from your application if the DLL does not currently exist, how can we determine that this is a genuine DLL? Well, let's attempt to create a new DLL and then overwrite this one. So here is another DLL which we're calling version 2. This has the same named function, which is exported from the DLL, but rather than dividing by 2, it's dividing by 3. So let's compile that, and we will copy that DLL version 2 into our test area. At the moment, your application is looking for simple DLL.dll. If we erase that file and rename the first one as the same name, and then attempt to run our application once more, we will see it has the original value of 10 and the new value of 3.3. This is because it's dividing by 3 in the new DLL. So substituting another DLL for the same name means that it's still going to be run in your application and it will fool your application to thinking that the DLL is already present. So how can we tell that the DLL that is in the folder is the one that's inside your resource? Can we compare the two? In order to verify this, we're going to have to add a couple of new libraries inside this application to allow us to perform a file hash on the DLL. We've covered file hashing in previous videos, so I'm not going to go into these to include files in detail today. But what file hashing basically does is we'll take either a string or a file and boil it down to one string of characters. This will give you something unique as a string that can be compared to another string. So we can compare the string that's in a resource against the string that's returned when we file hash the DLL. If those two strings match, then the content of the DLL is exactly the same as what's in our resource. If they return a value that's not the same, then it's not the same DLL. So let's put that check inside our application. So where we test for the presence of the DLL, we'll need to perform a check hash value if the file already exists. So we're going to create a new function called check hash value, taking two parameters like we did with the save resource function. The first being the name of the DLL and its path. The second being the identifier of the resource inside our application. If this returns false, then the hash value is incorrect. And if that's the case, we want to overwrite that DLL with the one inside our application taken from the resource. We can do that just by reusing the save resource command to push out the DLL to our folder. And if the value returned is true, then we know the hash value is correct for both files. So we will put a message out to our log to say the hash value is correct. So let's now go and create this new function, check hash value. So here is the skeleton of our new function taking its two parameters. Our first task within this function is to determine the hash number of the file itself. We can do that quite easily by using one of the functions in our new library. So we're creating a local variable to store that hash value. And we're using the getSHA function to obtain that. it takes the parameter holding the path and the name of the file, and we're printing this hash value out to our log. Next, we will get the hash value of the resource itself. Firstly, we will create a local variable to contain the resource. And as before, we will use the resource $command to extract our DLL from the resource. Now we need to determine the hash value of that string. So we will create a resource hash string to contain that value. And then we will call a couple of functions within our new library to obtain that value. And just for clarity, we will then print that value out to our log. Now that we have both the file hash and the resource hash, we can now directly compare them. If these two values do not match, then we return the value false. If they do match, we return the value true. So let's compile our application, and we will copy that into our test area. If you will remember, the DLL that exists in here at the moment is the second one, the one that divides the input value by 3. So if we run our executable now, it will tell us the two hash values, and as we can plainly see, they do not match. So the hash value is not correct, and the resource has been resaved into that DLL file. And we then run the function, giving it the input 10 and getting out the value 5. So it's now dividing by 2. So the original DLL has been rolled back to the file. If we run the application once more, it will tell us that the file hashes do match. This is because the DLL is the original version. So in summary, what we've done today is we've used the resource commands to store a CSV file within the resource section of our application. When our application runs, this file can be extracted back to disk. Of course, you don't have to save it to disk. It could be just kept as a string inside the application. Additionally, we have created a DLL and also embedded that within the application. And when our application runs, that DLL can be deposited, if it does not already exist, into the file structure. Additionally, we have checked the veracity of that DLL by comparing a file hash with the resource hash. If this value is not the same, then we can re-extract the DLL from our resource in the application and save it to disk. This gives you an easy way of checking file hashes on files. Hopefully you'll find these techniques and this code useful in your own applications, but that's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.